Finally spotted at Tesla's Fremont factory, Elon Musk's highly anticipated 2026 Tesla Model 2 has been caught in perhaps the most revealing leaked footage to date. And what we've seen inside this prototype might genuinely surprise even the most loyal Tesla followers just months after Musk boldly stated, and I'm confident that will be available in many cities in the United States by the end of this year. This is not just a new step in vehicle design, but a complete rethink of how vehicles are built. Before we go deeper, pause for a second. If this kind of real, under-the-surface content lights up your curiosity, then here's the deal. This is your moment. Hit that subscribe button not with your finger, but with your vision bic. This channel, Amp Drive, is built on pure passion for the future of technology. And guess what? We're still under 1,000 subscribers. That means every single one of you is not just a viewer, a founding pioneer of a revolution in how this story is told. So, what exactly is inside this long-awaited Model 2 that made Elon Musk declare it a revolution in design and production? While most videos only show you blurry spy shots, this one is about looking under the skin into the mechanical and structural DNA of the car. You will not find this breakdown on Tesla's official site or from traditional media outlets. If you're ready to uncover what old automakers and rising Chinese electric vehicle challengers do not want you to find out, you are right where you belong. Now, observe this. How does the wheelbase reveal a radical shift in Tesla's chassis thinking? When we examine the leaked image closely, we notice that the wheels, both front and back, are placed unusually close to the edge of the car's body. The space left for the suspension to absorb forward and backward forces is almost non-existent. But this is not just some stylistic decision. It proves a complete change in how Tesla approaches automotive engineering right now. By comparing the ratio between the axle and the edges of the car with a Model Y standing next to it, we estimate the front axle to front end distance at about 540 to 580 millimeters. At the rear, it is close to 490 to 520 millimeters. Now comes the big twist. The Model 3 has those same measurements at nearly 855 millimeters in front and 835 millimeters at the back. That's a huge drop, almost 300 millimeters less at both ends. You might be thinking 300 millimeters? Is that really a big deal? But in the world of automotive design, that's enormous. Traditional suspension systems require between 700 and 800 millimeters of space between the axle and the nose of the car. That area is where crucial components like suspension joints, cradle systems, auxiliary drivetrains, crash buffers, and even deformation areas for absorbing impact go. If Tesla cut that space down to around 500 millimeters, it means one thing: they got rid of traditional setups. This is only possible if Tesla fully integrates the suspension and drivetrain into front and rear GigaCast units without relying on the usual subframes and mounts, just like what they've done with the drive unit inside the Cybertruck. This points to unibody GigaCasting at its most advanced. The front and rear body sections are molded with the suspension elements already inside. Even the motor drive unit connects directly, forming a single solid structure. Tesla is not just using GigaCasting to bear loads, they are building an all-in-one drivetrain frame, combining everything into one cohesive chunk. This eliminates bulky cradles and cross members, and removes almost all of the traditional connection methods. That kind of approach is normally reserved for elite race cars like those seen at Le Mans, never for an affordable electric vehicle meant for everyday people. This tells us something even more important. The Model 2 fits perfectly in the A+ and B segment urban hatchback category, able to turn within a circle smaller than 5 meters in radius. Perfect for tight European streets or downtowns in the United States. Could this be the first ever mass-market electric car to bring race-grade chassis casting into the city? Drop Wheelbase in the comments if you believe this was not some random design accident but a bold message that Tesla is rewriting the entire rulebook of car making. Keep watching. What we found in the back roof design is equally astonishing. From the B-pillar all the way to the back of the car, the roof geometry tells a very different story compared to Tesla's usual style. Instead of a smooth, continuous curve like on the Model Y or Model 3, the roof sharply breaks at the C-pillar, forming an angle of about 20 to 25 degrees between the top roof and the rear glass. That sharp break is no design coincidence. It's a giant clue. Tesla typically uses a roofline with a consistent radius of 2.5 to 3.2 meters, creating a balanced aerodynamic arc from the front glass to the rear. But in this prototype, the radius of that curve drops to almost nothing after the SCPEIR. It looks like the rear part of the roof is not even connected. It seems like it is floating. We also notice a clear and unusual gap between the SCPILR and the rear spoiler. Measuring against the wheel size, this gap is estimated in around 55 to 70 millimeters. This sort of spacing has never been seen before in any Tesla model. And that detail is key. What it shows is that the rear portion of the roof might be a separate module removable or even swappable. This could be the very first real-world test of the modular roof concept that Elon Musk has hinted at since the year 2021. Imagine the possibilities. The entry-level version could come with a simple laminated middle roof, costing only around 85 to 110 United States dollars. A step-up could bring a full glass roof, priced at roughly $320 to $380. And the high-end variant might offer a solar-powered roof that generates around 180 to 210 watts of electricity, with a price between $600 and $750. Even better, this entire system might use just 4 to 6 clips, one data connector, and a 12-volt power line similar to the tent mounting mechanism found on the Cybertruck. The rear spoiler at the CPILR brake could also be modular, easily installed or removed depending on your vehicle trim. This would make the aerodynamic drag similar to the Model 3 between 0.21 and 0.22. So, with one base body, Tesla can sell 3 distinct roof setups, keeping manufacturing consistent but expanding choices for consumers. This is customization Tesla style, not just for luxury buyers but for everyday people. Think of it like snapping on a new phone. Case only now, it is your car's roof. Still following? Good! Because what we uncovered next about the rear quarter panels might be the biggest shift of all. Focus your attention just behind the left rear wheel. You will see 2 very distinct vertical cuts separating the rear from the main body. This has never been done on any Tesla model, not even the Cybertruck. Usually, in Tesla models like the Model 3 and Model Y, the back end from taillights to bumper is made of a single large welded piece. But in this prototype, Tesla has sliced the rear into at least 2 separate modules. The first is a lower rear component containing the bumper, taillights, cooling grills, and possibly a secondary battery or reverse sensor. It likely measures around 1,350 to 1,400 millimeters wide and 400 to 450 millimeters tall. The genius of this? It can be removed in under 15 minutes with fewer than 10 bolts and a signal wire. If made from plastic, the replacement cost could be between $120 and $180. If it includes vertical LED lights, like those seen in the Model 3 Highland, the price might rise to $300 or even $350. The upper portion, called the hatch, module includes the rear glass, spoiler if installed, hinges, and cameras. It measures around 750 to 800 millimeters in length. With a similar quick-release system, Tesla could offer basic versions without spoilers and premium versions with sporty grills or wider cameras. Why is this massive? Because Tesla is using a strategy called service-centric panelization, something previously found only in vehicles like MC Laurent supercars or electric delivery vans like Rivian EDV. Rear collisions are a major cost burden in cities. Almost 50% of city crashes under 40 miles per hour are rear-end. The average cost to fix a Model 3 rear is over $1,800. With this modular system, that repair cost might drop below $400. That changes everything. And now, the final clue hidden in plain sight in the paint. The prototype's glossy white midsection is not a wrap. It is a special paint. Tesla may be testing a new electrochemical formula known as heat shield white. It could lower cabin temperatures by as much as 17.6 degrees Fahrenheit when parked outside. This would reduce air conditioner power usage by about 13%. That means longer range in summer 5 to 7% more, especially with small batteries. The prototype's glossy white midsection is not a wrap. It is a special paint. Tesla may be testing a new electrochemical formula known as heat shield white. It could lower cabin temperatures by as much as 17.6 degrees Fahrenheit when parked outside. This would reduce air conditioner power usage by about 13%. That means longer range in summer 5 to 7% more, especially with small batteries. Even more important, only the middle section of the car is painted. The front and back are still wrapped in fabric. No wrap lines, no sticker edges, and no fake decals. This proves Tesla is now painting just the body center, saving time and paint materials. The old full-body paint cycle takes 42 to 45 minutes. With this partial method, the process drops to about 24 to 26 minutes. It also gives Tesla massive flexibility. A single center shell can be used across the globe. Different bumpers and accessories can be added at final assembly, matching local regulations and customer preferences. This strategy, called post-paint final zoning, is being trialed at Giga Berlin right now for the Robo-Taxi. The result? Production at Fremont could rise from 475,000 cars a year to over 950,000 on one line. With 2 lines, Tesla could push over 2 million Model 2 vehicles annually just using Fremont and Giga Texas. Every part of this prototype, from the frame to the roof to the paint, is a message. Tesla is changing how cars are made, how they are fixed, and how they evolve. Not sometime in the distant future, but right now. Are you ready for more? Let us know in the comments, and if you have not already joined the AMP Drive family, now is your moment. Hit that subscribe button and let's drive the future together.